Alright guys, welcome back. This will be the third video that we're making for our first unit of geometry. Again, just kind of getting that foundational information, all these different topics and concepts that we're going to need for the rest of our class. Okay, so for today, hopefully you're keeping your notes in order. We are going to go through 1.3. We've talked about points, lines, and planes. We've talked about midpoints. We've talked about segment bisectors, and now we're getting into angles. So we use lines a lot in geometry, and then angles is one of the key concepts that we need to understand if we're going to make it through some of these chapters in geometry. Okay, so for today, label is going to be 1.3, types of angles and bisectors. Date today is either the 16th or the 17th, depending on whatever day you have this class. Again, as a reminder, that's always optional to add the date. Objective for today, you do not need to write this down. Want to be able to identify different types of angles, which you guys may have seen this in past math classes before. If not, this will be good information. And then want to be able to use those different types of angles to find or to determine what kind of angles they are. So that's basically the idea. Can I identify them, and then can I use that to solve different problems? Okay. So with that being said, the first definition that we need to know if we're going to talk about angles, and I'll move myself up here. Okay. If we're going to talk about angles, the first thing that we need to understand is what a ray is. Okay. So a ray is a type of line. And actually I'm going to switch this up here because I think this pen's a little bit bigger than I want. Okay, yeah, that's a little better. A type of line that has one endpoint. So we talked about segments before. They have two endpoints. A ray just has one endpoint, and then in the other direction it just extends infinitely. Extends infinitely in one direction. Okay, so a type of line that has one endpoint and then extends infinitely in one direction. If I want to draw a picture of this or see what this looks like, I just need to draw exactly what it says here. So I'll just put this up to the top. So I have a point. Remember, we name points by a capital letter. You can choose whatever letter you'd like. Let's just say point A. And then we have a ray that goes out that direction. And we could have another point on this ray. If we'd like to, I could add point B. But notice I still have this right side of the line infinitely going to one direction, meaning that ray is still going to keep going. Now B is there, that segment is AB, but the ray just keeps going. Okay? So that is a ray. If we're using that with an angle has to use a couple different rays in order to be created. So an angle is two non-collinear, make sure to add that piece in there, two non-collinear rays that have a common endpoint. Okay, an angle, if we're using a technical definition, is two non-collinear rays that have a common endpoint. Okay, so if I wanted to draw an example of this, see what this looks like, I'll draw one ray here. Okay, remember we do need to name this point. We don't want to just leave it there, so we'll just call this point C, just to go along with our last example. And again, there could be a point up here. We can name this point D, doesn't matter. This would be ray CD. Okay, again, remember we talked about this with lines. Anytime I want to name them, same thing goes for rays. I just need 2 points on that ray. So this would be ray CD. And then if I want to create an angle, I just need another ray that has the same endpoint. So since our endpoint is C, let's say we have another ray going out a different direction, but still has C. Okay, and we'll name this E here. Okay, we'd include that. We can't include that, we don't have to. Okay, but they have the same endpoint. So this would be considered an angle. And usually what we do, if you guys have seen this before already, is if I wanted to measure this angle, I'm always looking for this measure right here. Kind of the distance or the degree between those two rays. Okay, and we'll kind of talk more about how to measure angles and what that looks like, but that's the basic idea. Okay, another thing that we need to add with this, with naming, because we've talked about naming, that's very important with lines, very important with angles as well. Probably one of the most important things that we'll talk about today that you're going to use most days in this class. Okay, naming an angle, you need all 3 points that make up that angle with the vertex in the middle. And I apologize that I'm kind of cramming all my notes in one little area here. Okay, but all 3 points, kind of try to divide this out a little bit. I need 3 points, so with lines we said 2, with angles we need 3. We need all 3 points that make up that angle, and then we need the vertex to be in the middle when I name it. So if I'm looking at this here, if I see our diagram that we've drawn and I wanted to name it, first thing that we're going to do is we're going to use a symbol to describe an angle instead of writing it out. So in the same way that we put a line above the letters, instead of a line above them, we're going to put a symbol before them. So we're going to put this little angle symbol here. It looks just like that, okay? This little angle symbol, and then I want the 3 points. So I see I have point C, point D, and point E, but I can't just name it that. I need to make sure that the middle letter, the one in the middle, the second one, is going to be my vertex, what we call our vertex, or in other words, that common endpoint. So this would be angle, for instance, DCE. And then I should be able to look right through that and see when I go through my angle, I go to point C, I go to point D, I go to point C, and then I go to point E. And I can just follow that track. And again, that common endpoint is in the middle of when I name it. Very important that you use that, okay? So with that being said, I did mention that phrase vertex. I want to make sure we understand what that means. Okay, a vertex, I'll write this down here. The vertex is, the common endpoint of an angle. Okay, so just making sure we understand what that word means, the common endpoint of an angle. Okay, so where those two rays meet, or that common endpoint, the vertex, that kind of corner piece, that's where our vertex is always going to be. So if you ever hear me use that term, hey, make sure your vertex is in the middle, I'm talking about basically the middle of that angle. Where do those two lines or rays come together? Okay. One other thing that we can mention with angles here is we measure them in degrees. Okay, so I'm going to put this here as well. I want you to write types of angles, and I'm going to add this before we get on to the types of angles. With types of angles, I'm going to say measured in degrees. So here I'll write out the degrees. That is the degree symbol. Measured in degrees from 1 to 360. Okay, degrees are measured, or angles are measured in degrees from 1 to 360. Okay, and the way this works is it's kind of like a circle, or it's going around in a circle. So if I start and I have a ray right here, okay, and you can draw this if you like, you don't have to. If I started right here and I had, this is where my angle ended up, say for instance, look like this would be about 1 degree. Okay, and as I start to go around that circle more, I'll add more degrees. So if I went this far, that would be about 1/4 of it. So if I'm thinking it goes from 360, if I think about that as 1/4, if I divide that by 4, that would be 90 degrees. Okay? If I went about halfway around the circle, try to keep this on the screen. Here, we'll throw this somewhere else. We'll go here. Okay? If I go 1/4, that would be about 90. If I keep going, that would be about halfway. Half of 360 is going to be 180. If I kept going, that would be 270 here. And then finally, if I go all the way around and I have a whole angle, or an entire circle that I just created, then that would be 360. Okay? So we have different types of angles that or different names for them that we use to identify them. Okay, so a right angle, I'll have you write this down. A right angle has a 90-degree measure. Okay, it has a 90-degree measure. Okay, and with all these examples, we'll draw a picture with it as well so we can visualize this. Okay, so with a right angle, if we're going to draw a picture, we'll always start with a flat line. And then again, we said we want to go 90 degrees, so that's about a quarter or a fourth of that whole circle. So it's going to look like this. It's going to have one line flat and then one line straight up and down. And then one other way that we use, this is only for right angles specifically, we use to designate them and make sure we understand that they're a right angle, is if we know it's 90 degrees or we know it's a right angle, we put a little box in the corner, or we put a little box by that vertex. Okay, so that is a right angle. Okay, an acute angle has less than, I'll write it out even though I could use the symbol, less than 90-degree angle. I'll get this out of the way here. Okay, if I measure it and I tell you, or it says that it's less than 90 degrees, then that is going to be what we call an acute angle. Okay, so again, if I want to draw a picture of that, I'll start with a flat line here. And then what I want to do to show that is I basically just want to make sure if I'm going around that circle, I just want to stop before I hit 90. So I could just wait till, or I could stop right here. And this would be considered an acute angle. Okay? Keep going here. We'll try to get through the last two here. An obtuse angle, I want you to take a second, I want you to write that down as well. An obtuse angle is the opposite of an acute angle. So acute, we said it has less than 90 degrees. Okay, acute, or an obtuse angle, has measure more than 90 degrees. So if I'm thinking of rotating around that circle, I go past 90 degrees and I keep going. Okay, so in this case, we'll draw our flat line. We start kind of going through here. This is 90. We keep going, and we can stop anywhere over here. Has more than 90-degree angle. Okay, again, you're just thinking about rotating around a circle. And the whole circle is 360. Okay, and then last one, a straight angle. Very easy one to remember. It has an exact measure, or an exact degree. And it has exactly a 180-degree measure. Okay, it has exactly a 180-degree measure. So again, if I'm thinking about the flat line that we have here, I'll give you a sec to write all that down. If we think about a flat line, if I start going in a circle and I want to get to 180, we know that's half of 360. So that's basically halfway around the circle. So I keep going, and keep going until my line is flat. And so really, if I keep going here, it just stops over here, and I just have a flat line. Okay, a straight angle. Why it's called a straight angle is it's legitimately just a straight line. Okay, we don't use that a lot, but it makes it a little easier to see. If I see a straight line, we know every straight line has a measure of 180 degrees, and that will come up next lesson. So make sure we understand that. Anytime you see a straight line in this class, that if I ask you what the angle measure is, it's always just 180 degrees. Okay, so that's a lot of filler and information. Hopefully we can use this now to kind of move through some of these problems a little bit quicker. Okay, so example 1, I want to identify the type of angle from the given information. So here's what I want you to do. I want you to take a second, I want you to pause your video, and I want you to sketch this diagram here, this one on the left side. Make sure you include all those points, and then I want you to just write this piece down as well. And you can write that to the right side of the page, and then we'll come back together, okay? Okay, so hopefully you have that written down by now. Hopefully these problems should go fast. It's asking me to identify each type of angle. So if I look at angle DBC here, I look, again, I want to just go from point to point to determine which angle it's talking about. So I'm going to start at D, go to B because that's the next letter, and then C. And you notice B is the vertex, so that's the one that's in the middle. Okay, so the question is, what type of angle is this? Well, I see if I'm thinking about how I go around the circle, 90 would be right here. This is past 90, it keeps going. Okay, so this would be obtuse. That is an obtuse angle. Okay, and I'll write angle with it as well. All you need to do for these kinds of problems. Okay, next one here, I'll erase my writing here. On part B, it says, how about angle CBA? Again, if I'm thinking about what angle it's asking me for here, because there's multiple angles, if you look at this picture, I want to just go from point to point. So start at C, go to B, and then go to A. So it's talking about this angle right here. What would that be? Again, B is the vertex, it's in the middle. Well, again, we see that's a straight line. We just talked about this. That is what we call a straight angle. Anytime it's a straight line, that is called a straight angle. Very important. We know that measure is 180 degrees. Okay? And then last one here, it's asking for angle DEF. And if I'm using this terminology, remember we have this angle, just as a reminder, angle is the symbol that we use here. Okay? This M, if you ever see a lowercase m right in front of this in cursive, all that's asking for is the measure of. Okay, it's saying the measure of angle, and then DEF is 33 degrees. So I don't even have a picture of it, but I'm already telling you this is how many degrees it is. Okay, so numerically we can still figure this out. We say, okay, I look back at my definitions, 33 I know is less than 90, so that has to be an acute angle. So I'll write that in here, acute angle. Less than 90 degrees. If I see any number with that, less than 90, that's going to be acute angle. If I see any number over 90, that's going to be obtuse. Okay, and then again, we see this degree symbol as well. Make sure you're always marking that on all of your angles. Okay? All right, hopefully that was simple enough. Moving on to example 2. Again, we're given this diagram. I want you to take a sec, pause your video, and I want you to sketch this diagram for me. Make sure you include all those points, and make sure you include this pink box right here as well, because remember, that tells us something about that angle. Okay, I'll give you a sec to do that. Okay, so hopefully if you're coming back, that means that you have sketched this diagram. If we're looking at this, I want to use this to, again, identify the following angles. So if I look at angle MJP here, again, I'm going to do that same step, just getting that habit of following the points. So going M, J, and then P. It's asking for this here. And there's sometimes we're going to see diagrams where it might look like it's an obtuse angle, or it might look like it's a right angle, but I don't know for sure. And that's why it's so important that we drew this box in here. Remember, this box tells us, and we see it goes across these lines here, okay, that tells us that that is a right angle. So if I look at angle MJP, that is 90 degrees, that is a right angle. Okay, and you see right angles all the time when you're looking at a corner of anything. If you're looking at a corner of a TV, corner of your laptop, whatever, those are always right angles, right? Okay. Next one here, if I'm looking at LJM, I'll erase what I've already drawn on this. Again, follow those points. I look at L, J, and then M. Again, J is my vertex, so that's in the middle. If I'm thinking about that, I see it's this small. I understand that 90 would have to be way over here, so it's less than that. So that is an acute angle. Very small measure. Could be about 10 or 20 degrees or so. Okay? And then last one here, if I'm looking at KJN, move myself out of the way. If I'm looking at KJN, follow the same points. Just start with K, go to J, and then N here. Hopefully by now we're getting the habit of this and understanding this. If I started at KJ, this flat line, and I just kind of slowly started rotating, okay, or I guess for you guys it would look this way, okay? Eventually what that's going to be is we know it's going to go past 90 and then it's going to keep going. So that's going to be an obtuse angle. That's all we're looking for in these kinds of problems. Is it 90? Is it less than? Excuse me, is it less than, is it more than, or is it just a straight angle, okay? All right, last thing here, we'll try to finish up. Very important definition that we're going to write down, an angle bisector. An angle bisector. And if we're thinking about what we talked about last time with segment bisectors, you can kind of guess what this is going to mean. Okay, an angle bisector is just a line that divides or cuts, a line that divides / cuts one angle into, can we erase that? Yes, we can. Into two congruent halves. Okay, so take a sec, think about that there, a line that divides or cuts one angle into two congruent halves. It cuts it in half. Okay, both halves are congruent, which we talked about earlier means equal measure. Okay, so if I have a 90-degree angle, so a right angle, say for instance, and I bisect it or I cut it in half, now each of those are going to be congruent halves. If I think of half of 90, each of those are going to be 45. Okay, that's what an angle bisector does. All right, so last step here, last thing, I will move up here. Okay, given this diagram, I want you to take a sec and I want you to sketch this diagram before we go through this, and then we will come back together. Okay, so last thing here, given that in K, so I'm going to mark this on my diagram, should have it written down by now, in K bisects angle JKL, so I'm going to mark that here, JKL. Okay, it bisects that. If measure of angle JKN is 8x minus 3, and measure of angle NKL is 6x plus 11, find the measure of angle JKN. Okay, so a few things that we need to do with this before we start getting into this problem if I want to understand how to set it up. First one here, if I'm looking at measure of angle JKN, try to use a different color here. Well, JKN, if I follow that, is right here. Okay, it looks acute, and that is going to be 6x plus 11 degrees. So I'm going to mark that on my sheet or on my diagram right now, 6x plus 11. Okay, and we're also told, sorry, I kind of went out of order there. We are also told, oh geez, okay, I'm throwing you guys off here a bit. Let me rephrase that. JKN was 8x minus 13. Sorry about that. JKN was 8x minus 13. There we go. That looks a little better. Okay. Now, let's look at NKL. NKL, if I look at that here, let's see if I can find a different color. NKL, we were told that is 6x plus 11. That's the one that's 6x plus 11. There we go. Okay, making mistakes so that you guys can catch those and catch your teacher on different things. Okay, so we have these here. We're given all this information, and then we want to find the measure of angle JKN. We want the actual number. Okay, so we know if we want to do that, we only have it in terms of x right now. We need to figure out what x is. If I'm looking at this picture, we said NK is the angle bisector here, which means that these two angles, the green one and the red one, are congruent. So measure of angle, or angle JKN, is congruent to angle NKL. Okay, you don't have to write this out if you don't like to, okay, but I'm just showing you here's how we get this equation. Okay, same kind of thing when we were doing segment bisectors. Now that we know they're congruent, all we need to do is set up the equation. I know that congruent just means equal. So measure of angle JKN, excuse me, try to use a different color here. Okay, we know that is 8x minus 13, so I'm going to plug that in. Okay, and that is equal to, or congruent to, if I'm looking at measure of angle NKL, we already said that's 6x plus 11. Right? So we're just plugging these in, setting them equal to each other. And now if I just gave you this in algebra, hopefully you'd be able to solve it. Okay, so we're going to use algebraic steps. So we want to subtract 6x from both sides because we want variables on the same side of the equation. When I do that, I'm left with 2x minus 13 equals 11. Next step here, we have a negative 13. We want to get rid of it, so we add 13 to both sides. Cancel out. 2x equals 11 plus 13, which hopefully we know is 24. And then last step here, want to divide by the number in front of the variable. Bring this answer up here. And we get x equals 12. X equals 12. Okay? So we get that answer. Remember, if I ever find an answer, I always want to make sure, is that what the question was asking for? In this case, we have x equals 12, but it was asking for the measure of angle JKN. So last thing we need to do, just like we did on previous problems last lesson, is we need to plug this back in to figure out what the measure of angle JKN is. Okay, so we know measure of angle JKN, as we were told, as of right now, is 8x minus 13. And now we just need to plug in x. So measure of angle JKN is going to equal 8. And then instead of x, I'll plug in 12. I'm going to put parentheses around it anytime I plug something in. And then minus 13. So that equals here. If I'm looking at 8 times 12, I can either do that in my calculator or try to do that in my head. Hopefully we understand that is 96 minus 13. And then last step here, 96 minus 13 is just 83. Okay, so it is 83, and then I'm going to add the degrees on that as well because it is an angle measure. Okay, and that would be our final answer. All right, so hopefully this makes sense to you guys. You will be practicing a good amount of problems using this. Basic idea is I understand a bisector just creates two equal halves, so I just set them equal to each other. All right, rest of time today, and I'll kind of clarify this in the Zoom call if I need to, but the homework or assignment for today is going to be 1.3 homework types of angles. Okay, so you guys can go ahead and get working on that. If you have any questions, feel free to hop into Zoom and let me know. All right, thanks guys.